Hey, here we go. So we're looking at solving linear equations. We got a couple of examples here, nothing too complicated to start with. And so we've just got these 6 examples, some of them, just a couple of a mixed bag of things. I'll start with this first one, x plus 5 equals 12. And so what you're going to want to do is take the 5 and subtract it from both sides. This is a subtractive property of equality, and you are going to be able to leave yourself an x and a 7, because 12 minus 5 is 7. Why does this work? Well, what's happening here is you're taking x and you're adding 5 and subtracting 5, effectively leaving x all by itself, right? And so that is nice, because then you've got x is equal to whatever's left over here. But in order for two things to start out equal, in order for them to maintain equivalency, you must do the same thing to both sides of the equation. So if I'm subtracting 5 from this side, I must also subtract 5 from this side, okay? And so therefore we've got x equals 7 as our final result. And we can even check that by taking this 7 and placing it back into x here, and it turns out 7 plus 5 turns out to be 12. So what we were able to do is find the x value that satisfies this linear equation. Let's do b. That was a. B is 13 equals 9 minus x. And this one's basically the same thing. It's a little trickier because of this minus sign here. So let's pay attention to that. I'm going to subtract 9 from this side and from that side as well. And if I've got a positive 9 and a minus 9, those are going to cancel out. And then over here, I've got 13 minus 9, and 13 minus 9 is, I believe, 4. And what's left over here? A negative x. Okay? This is where a lot of people mix up. They forget the fact that this negative actually belongs to the x here, and they end up writing this, x equals 4, as their answer. This is incorrect. Because this negative sign needs to be maintained because it's in front of x. It's the coefficient to x. Now, you might say, well, how do I figure out the actual solution? Because I have to isolate x, not negative x. And so what we're going to do is multiply both sides by a negative 1, parentheses, negative 1. Now, a negative x times a negative 1 is a positive x, because a negative times a negative is a positive, and this becomes a negative 4 over here. So I'm multiplying. Okay. Checking again, if I've got 13, and if I take this negative 4 here, let me see if I can highlight the entire, just the negative 4. No. Well, whatever. Take this negative 4, and I bring it up and put it in for x. I'll put it in here, negative 4. A 9 minus a negative 4 is 13, because a negative 4 becomes a positive 4, and 4 plus 9 is 13, last I checked. And so there's B. Let's look at part C. Let me just go ahead and make this white. 2x equals 18. And this is a pretty, first time we've seen this, is I'm going to divide by 2 on both sides, right? Because if I'm multiplying by 2, I can effectively divide by 2 as leaving x all by itself, right? And then over here, I end up getting a 9, because the reciprocal, sorry, not the reciprocal, the inverse operation for multiplication is division, okay? And so that's what we've got. Double checking to make sure that we have the right solution. Again, if I put a 9 right here in terms of x, this is basically saying x is 9, and so therefore if I put a 9 there, 2 times 9 is in fact 18. Letter D. Negative 3x equals a negative 21. Very similar to letter C, but a lot of people would make the mistake and do divide by 3. The reason why they do that oftentimes is, this is incorrect, by the way. The reason why they do that oftentimes is because they well, this 9, I had to change the sign and subtract 9. And so if I have a negative 3, I have to change the sign and make it a positive 3. Well, it turns out for multiplication and division, you need the same exact sign. And so a negative 3 divided by a negative 3 gives me a 1 here. And these two effectively cancel out, leaving me just the x. And then the negative 21 divided by a negative 3 is a positive 7. And again, double checking to make sure that our number makes sense. If I put a positive 7 in right here for x, then what's happening is a negative 3 times a positive 7 is in fact 21, which was our original equation up here. That was part D. Let's do part E. We've got 2x minus 5 equals 15. Well, this is now a multi-step equation where we're going to be, for the first time, doing a few stages at once. And we're going to have to add this 5 and then divide by 2 is the proper procedure. A lot of students forget that they have to add the 5 and divide by 2, and it has to be done in that order. They'll maybe divide the 2 first and then add the 5, and that's going to be incorrect. So let's do add 5 first, add 5, and I'm going to be left with a 2x equals 20. And then I'll divide by 2, and I get x equals 10. Okay? Going back to why do I add the 5 and the first and do the divide the 2 second? Well, it has to do with order of operations, right? A long time ago, a bunch of mathematicians decided that the order in which operations are done should be in a specific way so that everyone follows the same rules. It's basically a way of sort of translating math and writing it down so that everybody's sort of doing the same thing, right? If I had done it the other way around, I would have gotten some other value for x that would not make the equation true. So for example, let's take a look. Apparently 10 is the correct answer, and 2 times 10 minus 5 is in fact 15, because 2 times 10 is 20, taking away 5, giving me 15. And so the only number that x could be is in fact 10, okay? Another thing that I oftentimes tell people is you've got brackets, then you've got exponents and roots, then you've got multiplication and division, and you've got addition and subtraction, right? Now, a long time ago, some nice math teacher told you that in order to simplify, you start inside the brackets, and then you do exponents, then you do multiplication and division, and then you do addition and subtraction. Well, it turns out for solving for x, you actually go in the other direction. Solving for x. So you do addition and subtraction first, and then multiplication, and then exponents and roots, and then you do brackets, anything that happens to be inside of a bracket. And so notice, what did I do first? I did addition first, and then I did the division here. Okay? So this is the order of operations. Simplifying, you go in this direction. Brackets, exponents, roots. Multiplication and division, addition and subtraction. Solving for x, you go in the opposite direction. All right? Let's now do part F. This is a multi-step equation here, right? And so I'm going to do 4x minus 6 equals 8x plus 2. Alrighty then, so let's take a look. For this one, I'm noticing that I not only have two numbers like I did beforehand, but I also have an extra set of x's, well, just an extra x hanging around. The idea is that I must get these x's onto the same side, and the numbers have to go all the way to the other side. So I'm going to do my addition and subtractions first, and then I'm going to see if I have any multiplications or divisions to do, all right? So I'm going to add and subtract the appropriate numbers. I'm going to add 6 to both sides. These 6's then cancel out. And at the same time, I'm going to skip some steps here, so I'm going to subtract a negative 8. I'm going to subtract a negative 8, okay? And we end up with these 8x minus 8x. These guys cancel out as well. Now over here, notice I put the 4x and the 8x sort of one on top of each other. Well, what I'm intending to do here is these are like terms here, these ones, 4x and 8x. And if I combine a 4x and an 8x through addition and subtraction, so it's basically what I'm trying to do here is do a 4x minus an 8x, while over here I'm doing a 2 plus 6. Well, a 4x minus 8x is a negative 4x, and a 2 plus 6 is an 8. Okay, now if you look closely, I'm actually very close to this equation over here, the 3x minus a 21, right? So at this stage, I am going to do my multiplication and division. Oops, somebody's calling me. I am going to do my multiplication and division here, and so I'll divide by a 4, and I'll divide by a 4, okay? And there we go, negative 4 that is, and so I end up getting x equals 8 over a negative 4 or a negative 2. X is a negative 2, all right? And if I again try to see if the negative 2 goes in there, let's check it out. I'll put it up here. It's 4 times a negative 2 minus 6 equals 8 times a negative 2 plus 2. Let's see if this works out. Here I have a negative 8 minus 6, because 4 times a negative 2 is negative 8, minus a 6, giving me a negative 14. Over here, I've got a 8 times a negative 2, or a negative 16, plus 2. Negative 16 plus 2 is, in fact, a negative 14. And so the only number that I could put into both sides here is the negative 2. And that will, excuse me, give me the result that I need. Okay? There we go.